Alright, in this video, I'm going to introduce you how to using the sixth formula here, right? This is considered basic because all the angles inside the trigonometric function is x, right? X, right? So you just have to memorize this sixth formula, or you memorize the first two and generate the last four. So, and this is the only sixth formula that you need to know. So there. Okay, let's see how to, I will give you many examples for these cases because this is very important. So for example, question 1, if I have y equals to sine 3x, right? Sine 3x, then you were saying, sir, the formula here is sine x. There are no sine 3x here. You can use this formula as a reference that you know that differentiate sine, you are getting cos. So, but you see how I differentiate this. So just as a reference, so you see that differentiate sine, yes, you are getting cos 3x. This is correct. Differentiate sine, you're getting cos, then 3x. But because of the function inside here, is no longer x, it's not x. So I have to differentiate the function inside here, 3x. So differentiate 3x, you will have 3. So of course the outcome here, you are getting 3 cos 3x. Right? You know that sine, you differentiate, you're getting cos. But you have to differentiate the function inside here and you write as a 3 there. So, second example. For example, if I have y equals to cos 3x plus with tangent half x. For example, tangent half x. This is a trigonometric function, right? This one plus with this one, so I can differentiate. So that's the formula, that's the basic formula. So let's see, differentiate cos. So we refer to the formula. Differentiate cos, you were getting negative sine. So it's okay. So now I differentiate cos, I have negative sine. You are still writing back the 3x, as 3x is the angle. Negative cos, you get negative sine 3x. But because this is a 3x, so you have to differentiate the 3x, you're getting 3, right? Okay, then you have done differentiating this. Now look at this one. Differentiating tangent. So you have to refer to the formula tangent. Differentiate tangent, you have secant square x, right? So means that differentiate tangent here. You will have secant square. The angle will still be the same, but you have to differentiate the angle inside here. So multiply and differentiate this angle. So you multiply with 1 over 2, right? Differentiate 1 over 2x, you have 1 over 2. Finally, you have done with your differentiation, which is negative 3 sine 3x, right? Negative 3 sine 3x plus with half of secant square half x, right? So this will be the differentiate form of this function. Alright, let's look at more examples. Alright, let's look at this. Tangent 2x squared plus 1. Oh, sir, the formula here is differentiating tangent x equals to secant square x. So what is the formula for this? No, you just need to know all the 6 basic formula, right? Then to differentiate these things, you have to refer to the basic formula. So now differentiating tangent, right? Tangent, as this is an angle just like x, okay? It's just an angle, right, of the tangent here. So this is a function, it's an angle inside the tangent here. So then I dy dx. So of course I need this formula here. So differentiating tangent, right? Based on this formula, differentiating tangent is secant square x. So secant square x. But this is not x. This is a function, the angle 2x squared plus 1, right? First step, differentiating tangent, you're getting secant square. And this one follow back. Then not end yet, right? So everything have to multiply with the differential of this function inside the angle inside the tangent. So which is differentiate 2x squared, you have 4x. Differentiate 1, 0, right? So you have 2 to 4x. So finally, your solution will be 4x secant squared 2x squared plus 1. So this is a differential form of this function here. Alright, okay, let's move on for the next example. Right, let's continue with these two examples here. So we have y equals to secant 3x, right? Secant 3x. So differentiating y with respect to x. So you have y is a second function, so 3x. So you refer to this formula here, right? Differentiate secant x, you are getting secant x tangent x. Remember that. Differentiating secant x, you have secant tangent. So see how I apply this. So, okay, you must see the patterns, right? The patterns. So differentiate secant, that is power 1. From here, you can getting secant 3x tangent 3x, right? The first step here is secant this angle, whatever angle it is, any angle, any function, all right? So as long you differentiate secant, you write secant tangent, right? Secant tangent. So this one is your, now it's your x, 3x and 3x. But, all right, this is the first step, right? You differentiate secant tangent, 3x, 3x, follow, just follow. So later, you differentiate the angles inside there, angles inside here. So you have 3, right? Then that's the answer, right? That's the answer, which will be 3 secant 3x tangent 3x. Very easy. Alright, if not understand, okay, you can try this one first before you view the video. You pause the video first. Alright, so now how to solve finding the differential of this is exactly the same, right? So they have a constant 2 here. The constant is doesn't matter. So, alright, let's see what I do. So your dy dx. So 2 is just a constant, right? So I start differentiating what is here, right? Differentiating this. So look at the formula secant. So you have secant tangent, right? Based on the formula, differentiate secant, you have secant tangent, right? So then 1 minus 3x squared. 1 minus 3x squared. So first step, I have using that formula. So followed by differentiating the angle inside there, right? Finally differentiate this one. Differentiate 1, you're getting 0. Differentiate negative 3x squared, basic rule. So it's negative 2 times 3, 6x, 2 minus 1, so 1. So this will be your answer. So you are getting negative 6 times 2, negative 12x. Second, 1 minus 3x power of 2, tangent 1 minus 3x power of 2. That's the function, right? That's the differentiate of this function. Alright, there we go for how to differentiate using cosecant and tangent, the formula. Right, let's see. Alright, let's move on with this example. So differentiating cosecant. Okay, differentiating cosecant 4x minus 1. So that's this formula is involved. Differentiate cosecant, you have negative cosecant cotangent. You just need to remember when you differentiate cosecant, you have negative cosecant cotangent. So same thing happen here. So dy dx, differentiating cosecant, you have negative cosecant cotangent, right? This will be the given angle. So 4x minus 1, 4x minus 1. Okay, done for the first part. Second part here will be differentiating the function inside the cosecant, which is 4, right? Differentiate 4x minus 1 is 4. So you are getting negative 4 cosecant 4x minus 1 cotangent 4x minus 1. As easy as that. Alright, you can pause the video and try question 7. Okay, so dy dx. So differentiate cosecant. The formula will be negative cosecant cotangent. So negative cosecant cotangent. So what is the angle? The angle is the angle given. So 1 over x, 1 over x. Okay, first step here, apply the formula. Second step, look at the function here. This is a reciprocal function. So it's x to the power of negative 1, right? So differentiate x to the power of negative 1. You will have negative x to the power of negative 2, right? So overall, you will have negative, negative, positive. X to the power of negative 2 is 1 over x squared. Cosecant, 1 over x. Cotangent, 1 over x. That's all for this function. So then we go for more example, differentiating cotangents. Alright. Differentiating cotangent. Differentiating cotangent, you are getting negative cosecant square. Negative cosecant square based on that formula. So differentiating this, so you have dy dx, dy dx equals to differentiating cotangent. You have negative cosecant square, and of course the function you will be getting back. So the first step, right? So second step will be differentiate the angles of that trigonal function. So x squared, so you're getting 2x plus differentiating x, you have 1. So you're getting negative 2x plus 1 cosecant square x squared plus 1. That's the way you differentiating this function here. So let's go for this example. Alright, dy dx, differentiating cotangent. So you have negative cosecant square. So what's the angle here? Of course, you put back what is given. So first step. So second step, look at the function inside the angle function inside cotangent, which is ln. Differentiate ln x, you have 1 over x. So you are getting negative cosecant square ln x divided by x. That's the answer. So this is all the basics how to using this formula, right? This is a basic formula, and I have give you 9 examples. So we go through this example. So in the next video, we go to a trigonometric function with there is a power for this function here. So, alright, see you.